Everyone, welcome to Apex Hours. So in this series of videos, we'll be looking at OAuth 2.0 and specifically the identity flows that are used to authenticate and authorize users and issue access tokens, identity tokens, and refresh tokens. So firstly, just wanted to say a big thanks to Amit for having me on Salesforce Apex Hours. A little bit about me. So my name's Lawrence Newcomb. I work as an architect, primarily with Salesforce, but with in the context of enterprise implementations with other systems as well. I've been working with sort of medium to large non-profit organisations for the last 8 years, all involving Salesforce. I also spent time working with Salesforce as an open source developer as well, and I've worked a lot on the open source application Formula Share, so do check it out. It's on the App Exchange. It's completely free. It's for supporting use cases where there are particularly complex sharing needs that would otherwise require Apex sharing. You can also do take a look at my website. So a lot of the content that I'll be running through in these videos is available on my website. So all of the flows that we'll go through, the diagrams are there on my website, as well as descriptions and summaries of each of the flows. I'm also on Twitter. I'm Cloud Sundial there, so do come and say hello. So in terms of what we'll cover, so we'll be looking at what I'd consider to be sort of the main kind of core OAuth flows, which Salesforce is likely to participate in. So all of these are sort of generic identity flows for integration purposes. So there are some more sort of niche flows that we won't cover, but all these are probably the kind of the core ones to know for integrations, both with Salesforce as the auth server and Salesforce acting as a client application. In terms of people who should hopefully find this useful, so architects working with integrations, and particularly anyone who's studying towards architect exams, so either the CTA exam or the Identity and Access Management Designer exam. So there's quite a bit of overlap in terms of what I'll talk about with the contents of those exams. Developers working with integrations, so implementing OAuth flows, either the identity aspect or other elements. It's useful to know how this authentication happens. And generally, anyone who's interested or concerned about security in relation to integrations. There's hopefully be some useful information around security considerations. And of course, anyone who is just generally interested in identity. So in terms of structure, the way we'll organise this, so I'll give a run through of the sequence of steps in each of the flows, talk about what's happening between each step, the validations and so on that are made both by the client and the authorization servers. Any particularly interesting characteristics about each of the flows and things that you might want to consider when choosing whether to implement this flow for a given context. There's a few things that unfortunately we won't have time to go through in depth. So firstly, just the basics around OAuth. So I'm just going to assume that that everyone has sort of a working knowledge of OAuth 2.0 concepts. If not, there's a lot of really good documentation, both from Salesforce and in the wider ecosystem, running through some of the basics of OAuth. I'm also not going to discuss some of the more sort of specific use case flows that are available for Salesforce. So flows like the SAML assertion flow. So we will talk about the SAML assertion bearer flow, but not the SAML assertion flow. The asset token and device token flows, which are useful for a number of IoT use cases, but are kind of quite specific to those. And also OAuth 1.0 flows, which are still supported by Salesforce. I'm also not going to be talking specifically around practical implementation, though I will reference certain things as which are relevant to specifically to Salesforce, where those are particularly important. If I'm saying anything and it sounds like complete gibberish, do have a look at my website. I'm going to try to, rather than just sort of explaining everything as I'm going along in terms of technical jargon, I'm going to try to summarise the main terms and the main points on this page on my website. So do have a look there, or otherwise Google is your best friend. So firstly, just a few general prerequisites around setting up OAuth flows in general. So whilst I'll talk about prerequisites for each of the specific flows, there's a few things that we'll want to ensure are in place for OAuth in general. So firstly, that we have some secure HTTP-based method of communication between the client and the authorization server. So ultimately, the end goal of each of these flows is for the authorization server to issue tokens, which do need to be protected. So we'll want at least some of the communication to be over a secure channel, typically HTTPS. The authorization server will also need to be configured with a client application to allow the inbound integration to take place, and that client app within the authorization server will need to have within it set up a list of acceptable redirect URIs. So redirect URIs will be where the authorization codes or the tokens will be sent in some patterns. So we need that. So these will be URLs at the client application, and we need to ensure that those URLs are completely secure. So we'll want quite a short list of acceptable URLs. It's also generally advised to not allow pattern matching at the authorization server, is if there are any cross-site scripting vulnerabilities on any page at the client site, then there can be some risk of hijacking and cross-site request forgery. We also need the client to be aware of the client ID that's been configured for it in the authorization server, so that typically needs to be shared with the client in some way. The resources at the redirect URIs that I mentioned, so it's very important that all of those, that short list of redirect URIs, that measures are in place to protect against cross-site scripting. So generally those pages should be very pared down and very, very carefully constructed to ensure that there's no opportunity for that kind of attack. And finally, for flows where a mobile application is participating, so as where the mobile app is acting as the client, then we'll generally want the app to kick off the device's native browser. So that's the sort of generally considered the most secure and the most usable way of implementing an OAuth authentication. So this way, this allows us to use the cookies that are set on the native device, versus an embedded browser. We don't necessarily benefit from the cookies that are already set on the app's native device, a native browser, and it also provides a consistent level of security across all apps that use that browser. The first flow we'll run through is the authorization code with secret flow. And so this is the implementation in Salesforce, which is known as the web server flow. So to summarize this flow, the kind of the key aspect of this really is that there's a trusted client server application. So this is an application which can securely protect either a client's secrets or a private key, which is used to sign a JSON Web Token. So in terms of other requirements, so there's a browser involved in this flow, so it's an interactive flow. So there's user login potentially and authorization to the auth server. We expect also that as well as being able to protect the secrets, that there is secure communication between the client's application server and the authorization server. So that'll be a REST-based integration. And we would also want to ensure that as part of implementing this flow, that we're following general security best practice. So firstly, just to run through the steps of this flow and the main systems involved. So there are kind of 4 system components to this flow. So there's the browser, and so the browser that the end user, or also known as the resource owner, is using to access the application. The client app server, so this is a secure backend to the client application. The authorization server, so this is the system which is logging the user in, so authenticating the user, and also accepting their or checking their acceptance of the scopes that have been requested from the client app server. And the resource server, so this is the application where the protected resources reside. So the application that the client app server is requesting a token to access. So the flow starts with some action being taken in the browser that prompts the client app server to decide that it's time to request a token for integration. So the client app server then initiates the flow with a redirect to the authorization endpoint at the authorization server. So there's a few parameters set to this request. It's the client ID. This represents the unique ID of the client application in the auth server. The response type is set to code to indicate that we want an authorization code back rather than a token. The scope is set to the scopes that are required for the integration that's planned between the client app server and resource server. There's also an opportunity as part of this flow to request the ID token, so the ID scope, the open ID scope, and also the refresh token. So using the refresh scope. There's a redirect URI parameter that's specified here. This needs to be set to the URL that the authorization server needs to redirect back to the client's app server to respond with the authorization code. State here can be used in a couple of different ways. So the first is a security mechanism to protect against cross-site request forgery for the authorization code response. So this state can be set to a unique random value, or potentially part of the state can be set to a unique random value by the client app server, and the authorization server will respond with that same state. So this gives the client app server confidence that the response from the authorization server is made with knowledge of the original auth code request, and which can protect against some cross-site request forgery attacks. It's also optionally possible here to include a code challenge and a nonce. So these two parameters, in fact, all 3 of these, so state, code challenge, and nonce, are all typically used to protect against cross-site request forgery attacks of a slightly different nature. So they're all parameters which are provided at one stage and then checked against other parameters later on. And the code challenge in this instance, this is part of the proof key for code exchange pattern. So this code challenge is a hash of a random value that the client app server has set. And the client app server later in the flow with the token request will demonstrate that it had knowledge of the value that was hashed by sending the unhashed value later in the flow. So that comes in a code verifier parameter a bit later. So that code challenge and code verifier are helpful for the authorization server to be confident that the client app server that the entity making the token request is the same entity that made the authorization code request. The nonce is, so this parameter is, again, this is typically set to a random one-time value by the client app server, and this value will be sent back to the client app server in the ID token if they've requested an ID token. So for OpenID Connect implementations, this is also a helpful protection against cross-site request forgery attacks. So the kind of those three parameters all work in tandem. The state and nonce allow the client app server to be confident that the authorization server has not been, or that it can check from the responses it's getting from the authorization server that the cross-site request forgery hasn't taken place. And the code challenge allows the authorization, the code verifier allows the authorization server to check from its perspective that the client app server is the same one that made the original request. I mentioned there's two potential uses for state. So the other use is for the client app server to communicate information that it wants to ensure is included in the redirect, subsequent redirect. So this could be in an OpenID Connect implementation, for example. This can hold the ultimate URL that the user needs to be redirected to after the flow, and it can also be used to transmit to persist general information between the calls. So the next step, so this is initiated by the authorization server, is the authorization server will check, is this user logged in currently to the authorization server, and if they're not, then prompt the user to log in and authenticate. It then checks, is this user authorized, has this user previously authorized sharing of the scopes that are being requested by the client app server. So if they haven't authorized all of the scopes that are requested here, then the authorization server will prompt for agreement to share those scopes. And the authorization server also will check that the redirect URI that's provided matches one of the whitelisted URLs that are approved for callbacks to the client app server. So, this mechanism allows us to ensure that the authorization server is not passed a URL for redirect that is potentially not under the client app server's control or designed for this purpose. So the authorization server, following those checks, will then redirect to the redirect, the URL in the redirect URI, so the callback URL, and as part of that redirect, it will include a parameter with the authorization code, and also the state, as I mentioned, that can be checked by the client app server. And that authorization code is then used by the client app server to request an access token using an out-of-band HTTP post request. So, one of the real sort of crucial aspects of this flow is that this request happens without any involvement from the browser. So this is entirely a back-channel request, and as such, there's levels of security that can apply to this that wouldn't be possible through a browser. So this request will be made to the token endpoint of the authorization server, as well as the client ID and to associate to the correct app. This request will also include a client secret. So this is a bit of information that is known only to the client app server and is protected by the client app server. The authorization code is included here, and the grant type is set to authorization code. The redirect URI parameter is also included on the token request, and this needs to be set to the same redirect URI that was used for the original authorization code request. This is also, if the proof key for code exchange was used, this is also where the code verifier is included. So the authorization server will then check the client secret against the client ID that's been provided and check that those match the values required for this client app. It'll validate that the authorization code is one that it has issued. It'll check the redirect URI matches the one that was provided in the authorization code request. And assuming those checks are successful, it will issue the tokens as requested in the scopes. So this will be the access token and optionally a refresh token and also an ID token, depending on what was requested. The ID token, if it's included, will also include the nonce that I mentioned earlier as a parameter. So that allows the token to be bound to the original request. The message will be signed, so it can be checked against the authorization server certificate, and the scopes will also be included so that the client app server can easily check which scopes this access token is relevant for. So at this point, the client can then start to use APIs at the resource server. So by including the access token with these calls, the access token will be checked by the resource server, potentially in tandem with the authorization server, and those authorized requests will can be made. So based on the information that's come back from the resource server, then the client application server is then free to share the relevant information with the browser and provide whatever authenticated service was required. So a couple of things just to add to that. So in terms of sort of general additional security recommendations for using this flow. So I've mentioned there's these three mechanisms to help protect against cross-site request forgery, and also potential for token replay attacks. So proof of key for code exchange, PXE, state, and nonce. So these all provide slightly different protections, and the best protection would be to use all three. There are some attacks, some feasible attacks that would require all three to be in place, but certainly some combination of these. So nonce if OpenID Connect is being used, proof key for code exchange if it's an OAuth, a typical OAuth integration. And we also need to consider the consequences could be if tokens were to be compromised in some way. So generally, it's recommended to use mutual TLS authentication. So this involves a certificate at the certificate of the client app being checked at the auth server. So there's a couple of different ways this can be done. So potentially, the way that Salesforce offers this is that it allows a certificate to be uploaded as a digital signing certificate to the connected app. Salesforce is acting as the auth server. There's also mechanisms that this can happen using the certificates that are shared as part of the TLS handshake. But ultimately, the objective is to ensure that the client application is identified securely as the app server. It's also recommended just to use relatively short lifetime tokens with this flow, so both access tokens and refresh tokens, as it is with any other flows. So if we were to have tokens compromised, that that the risk that these being used for long periods of time is low. Also, just to mention, so there is a slight variation to this flow to using the client secret as I've described in the diagrams. So rather than a client secret, the client app server can potentially construct a job token and sign that job token so that the authorization server can then validate that job token and check that it was signed by the client app server. So this token is a little different to the job tokens in the job bearer flow, in the sense that it identifies the client app server rather than identifying a specific individual. So the client ID of this job token, the subject of this job token is set to the client ID of the app. So the considerations around when it's a good idea to use this flow. So firstly, this is the most secure version of an interactive OAuth integration, and so if the prerequisites are met, it's almost certainly the right flow to use. Because of the additional security that's provided through the secure client application and the secure back channel, it's generally considered a good use case for refresh token. Since we've got an application that's trusted to protect client secrets, or at least its own public key, we've typically got the infrastructure there to protect refresh tokens effectively as well. The browser elements of this flow, so the initial authorization code request, the risk of the parameters that are shared as part of that interaction, that redirect. If this is implemented well, and particularly if the proof of key exchange, cross-site request forgery protections are put in place, the risk of compromising the authorization code that's shared as part of that redirect is relatively low. And probably the only reason to consider not implementing this flow is if we don't have that mechanism of the secure trusted client application server